In the world of AI, we're always told that newer, bigger, more complex is always better, right? But what happens when you put a brand new, cutting-edge AI up against a classic, almost old-school model in a duel about creativity? Well, the result is pretty shocking, and it might just flip how we think about teaching machines to design. Let's get into it.
So, in one corner, we've got this modern deep learning beast, a convolutional neural network, or CNN. You've definitely run into these. They're the same kind of AI that spots faces in your phone's photo library. It learns by looking at pixels, just the final image. And in the other corner, a classic model called a random forest. This one's different. It doesn't even see the picture. Nope, it learns from the raw data, the physics, of how a line is actually drawn. And the battleground for these two? Figuring out the creative spark behind a designer's sketch.
All right, so first up is the modern AI. They throw a brand new set of sketches at it, stuff it's never seen, and its accuracy comes back at 82.5%. I mean, that's not bad, right? It's like a B-, pretty good, but you're not exactly going to bet the farm on it.
But then, the classic AI gets its turn, takes the exact same test, and the result? 100%. Perfect. A flawless score. It didn't make a single mistake.
Okay, so this is the mystery we're here to solve. How on earth did an older, arguably simpler model got a perfect score when the shiny new AI couldn't even get an A? The answer is, well, it's not just some technical quirk. It actually tells us something really profound about the right way to build creative AI.
So, to really get how this upset happened, we gotta go back to the beginning. Before a single line of code was written for either AI, the researchers had to do something pretty amazing. They first had to figure out the hidden language, the grammar of how a designer's hand actually moves.
And their method for this was just brilliant. They went on YouTube and found 20 video tutorials from pro designers sketching all kinds of stuff. Coffee makers, gaming mice, that sort of thing. Then they fed all that footage into a custom-built program that just ripped it apart, frame by painful frame. And in doing so, they created this totally unique data set of pure creative action. And I mean, you got to appreciate how much work this was. Every single one of those videos was broken down into this long sequence of timestamped frames. Then, a human expert had to go through and label every single stroke by hand. See, they weren't just looking at the final sketch, they were capturing the entire journey, the process of getting there. And once you pile all that data up, you start seeing these really cool patterns. Take a look at this heat map. It shows the designers actually change how they draw depending on what they're drawing. So for something like a gaming mouse, it's all about these defining strokes to nail that ergonomic feel. But for a clock, it's way more about shading to show the material and the finish. So, any AI that wants to get design has to understand this kind of context.
So, when they crunched all the numbers, a pretty clear picture emerged. The single biggest thing designers do, we're talking almost 40% of the time, is make what are called defining strokes. The lines that actually build the basic shape of the thing. And this is huge, because it tells us that sketching isn't just some random, chaotic mess. It's a structured process, a sequence of very deliberate actions. Okay, so now the researchers have this incredible, deep understanding of how humans sketch. It was finally time to bring in the machines. They set up the big showdown. Two different AIs, with two totally different ways of learning, were about to go head-to-head.
So, contender number one took the pixels approach. This is your standard modern deep learning technique. The AI, a CNN, was basically shown a little 256 by 256 pixel picture of a single stroke and told, hey, figure out what kind of stroke this is. So it's learning only from how it looks, just the final visual.
And the training process here was pretty much by the book for deep learning. You start with about 2,000 real strokes from the designers. But CNNs are super data hungry, so they had to puff up that dataset to 20,000 images using simple tricks, like flipping and rotating the originals. Then they trained 5 of the most popular CNN models on this data to see which one would do the best.
Now, the second competitor was completely different. It took the physics approach. This classic machine learning model totally ignores what the final stroke looks like. Instead, it gets fed data about how the stroke was made. We're talking more than 150 different features, things like the speed of the designer's hand, how hard they were pressing the pen, the curve of the line. It's learning the action itself, not the final image.
And yeah, the pipeline for this was totally different. For every single stroke, the system saved a little file just packed with metadata. From that raw info, the researchers then engineered, that is, calculated, over 150 specific features. And then they trained 10 different classic AI models, including our champion, the random forest, to see which one could figure out the patterns in all that data.
All right, so the stage is set. We've got our two contenders. One learns from the picture, the other learns from the physics. The results of this fight weren't just about winning or losing, they were about to reveal a crucial flaw in how we usually think about training AI for creative tasks.
And here they are, the moment of truth, the best of the fancy deep learning models. It topped out at 82.5% accuracy. Not bad, but the classic model, the random forest, it hit a perfect 100%. The difference is it's huge. The old school method didn't just squeak by with a win, it absolutely dominated.
So if there is one thing you take away from this whole thing, let it be this. Modeling the physics of the designer's hand flat out beats modeling the pixels on the screen.
But why? Why was the classic model so much better? Well, it all boils down to a classic AI problem called overfitting. See, the modern pixel-based AI, it didn't just learn what a defining stroke looks like. It accidentally learned a bunch of tiny, useless details from its training images, like, say, the specific way the drawing software made the edges of the lines look smooth. So when it saw a new stroke from the real world that was rendered just a little differently, it got thrown off. The physics-based AI, though, it learned the fundamental truths of the action, speed, pressure, curvature, and those things are the same no matter what screen you're looking at, which is why it could generalize perfectly to new data.
Okay, fine. An old-school AI won a nerdy competition. So what? Why does this actually matter? Well, it matters a lot because this discovery points toward a brand new and, frankly, much better kind of AI creative partner.
I mean, think about the big generative AI tools that are everywhere right now. They're amazing, right? They can generate a beautiful finished image of a sketch in seconds. But here's the thing, they have zero understanding of the process of sketching. They don't know the difference between a line that defines the shape of a car door and a line that's just adding a little shadow. To that kind of AI, it's all just a pattern of pixels.
A truly helpful AI partner, the kind we actually want, would need to understand the process, just like a human collaborator would. It would know that you start by laying down some light, constraining strokes to get the proportions right. Then you add the curved, defining strokes to build the form. And only at the end do you add the detailing strokes for emphasis. It needs to get the grammar of creating, not just the final words.
And that really brings us to the big final question, doesn't it? This research proves that we can teach an AI to understand the intent, the process behind a creative act, not just the final product. So if we start building on this idea, if we shift our focus away from just analyzing pixels and toward understanding process, well, could we be on the verge of creating the first true AI creative partners?